Hello peeps, what's up? Let's see today's problem from the August LeetCoding challenge. It is called sum of left leaves, and what we need to do, we need to find the sum of all the left leaves which are present in our binary tree. That is the leaves which are on the left side of some internal node, of any internal node you can say. So in this example there are only two leaves which are on the left side of some internal node, and leaf nodes that are 9 and 15. The sum comes out to be 24. We do not need to consider 7 here, so it is an easy problem. Let's see what we can do. It can be solved using the magic of recursion. What we would be doing, suppose we have a binary tree. We only need to find out the sum of the left leaves, which are this one and only this one. Do not need to add up the sum from this leaf and this leaf because it is on the right side of some internal node. What we can do, we can start our recursion from the root of the tree, and we can pass some value along our recursion called let's call it side. So if side is equal to 0, it means we are proceeding to its left child, and if value of side is equal to 1, it means we are proceeding to the right child of current node. So this is the info we would be passing to the descendants of current node. And if we have reached the leaf node, we will see if the value of side is 0, we will return its value that is present at this node. And if we are at the leaf node and the value of side is 1, then we won't be considering this value and we will simply return 0 from here. So let's see, let's dry run our code here. So suppose we start our traversal from here, we will pass 0 and we will only return any value when we have reached to the leaf node. So 0 0 1 1 1 0. So there are these 4 leaf nodes, 1 2 3 4. As at these two the value of side is 1, so we won't be returning any value from these leaf nodes. From only these two sides where the value of side is 0, we will return the value. Let's say the value present at these nodes are x and y, then we are sure that our function will return x plus y. Let's see the code now. This is the base case. If suppose the binary tree is an empty tree, there is no root, then we will simply return 0. Then I've called my helper function called solve on the root, and initially I'm passing the value of side as 1 because I do not need to return the value present at the root. It is not the left child of any internal node. So yes, if there is our recursive function has reached where there is no node, like if the root is null, it will return 0. This is the condition which tells us whether it's a leaf or not. If the leaf node, we will go into this if condition and we will see the value of side is 0, we are returning the value present at that node, otherwise we are returning 0. We are returning 0 because if the value of side is 1, then it means it's the right child of some internal node, so we do not need to consider it. And after that, if we are at some internal node, let's say this one, we are just simply adding up the answer we will get from this side and this side, that is from left subtree and right subtree. So I've called my solve function of the left subtree and right subtree and add up the answer, and I returned the summation of those two recursive calls. That's all for this problem. I hope you liked it, and if you guys are learning something from our videos, then please do subscribe, man, and like our videos. Take care, sayonara, see you in the next video.